Good day, folks. It's Tony Fortunato from the technology firm and NetAlly. Today we are going to follow up with the last presentation we did where we discussed how to capture packets and how to get in the way of the packets and different techniques to do that. Now we're going to talk about what do you do when you get those packets. So we're going to go through all the tips and tricks, things you got to keep in mind once you get those packets in hand. Enjoy. All right, we're going to start right from the beginning. Doesn't matter if it's packet analysis, troubleshooting, or whatever you're working on. This has got to be the most important slide you concentrate on, and that is establish a clear and concise goal. Now, it can be a goal, it can be a target, it can be a milestone. It doesn't matter exactly what it is, but make sure whatever you agree on is very clear and very concise. The problems you run into, it's called scope creep in the consulting world, and that it's quite simple. They bring you in for one thing, and next thing you know, they keep adding and adding and adding and adding, which would be okay if you address everything they wanted, but that usually never happens. And you've got so much stuff to do, you didn't even finish the first thing. So keep that in mind. You don't want to fall for that. So in this case, I've got some examples here. We've got boot up baseline, login baseline, application baselining, VLAN or subnet broadcast analysis. I've done tons of videos showing all of these topics. Configuration validation is a big one these days. The thing to keep in mind here is whatever you choose, make sure it's measurable, make sure it's achievable, make sure you can actually deliver that before you get strung into something else. And here you can see there's a laptop, and there's a desktop. You want to make sure the configurations are working as advertised. You're not doing anything else in the background that they shouldn't be, so on and so forth. You got your good old VoIP phone. Where's it downloading its config from? Is it downloading config every single time? Does it do firmware updates? Where's that coming from? What protocols? What servers? Where are they located? In the cloud, on-prem, that kind of stuff. And of course, now we've got good old IP cameras. Same deal. Where are they talking? How are they talking? Who are they talking to? That kind of stuff. More importantly, with the cameras, if you do have video streams in-house, is it just staying in-house? Is it going out to talk to certain servers to look for firmware or updates or whatever it's trying to do? You have to learn a little bit about all these products to make sure you understand why they're doing what they're doing. Best case scenario, you find a liaison on site who knows something about that equipment very well, and you match up the packets to what they think should happen. All right. I thought the best way to demonstrate what I was just trying to explain in the previous slide is an example. And that's what I got here. So we've got kind of a clear and concise goal with a VLAN discovery, a subnet analysis, broadcast analysis. They're called different things. And what I want to do is show you an example of what you want to do and what you don't want to do. So we've got notes, capture filters that are being used. In this case, my laptop did the capture. I excluded my MAC address. It's worth noting. In some cases, you want to include your MAC address if you were to pursue some kind of DHCP analysis, and then you can find out if there are any helper addresses being used and what those IPs are. We've also got down here that there's no span or tap being used. And that's important because you want to make sure people can replicate what you've just done. The last thing you want to do is have this thing all so specific and unique that nobody else can ever do it, and you'll be stuck doing the same job for the rest of your career. You want to be able to pass this down to somebody, mentoring and training and all that good stuff. And we'll talk again about that just a little bit later. But you want this to be fairly, I'm going to say straightforward. Capture duration, in this case, it's 10 minutes. You want to make sure you note that as well. With Wireshark, I can actually tell Wireshark to stop capturing after 10 minutes. So you don't have to watch your actual watch or anything like that. And the results are fairly straightforward. This one's the percent of total traffic flying around the network. Again, with no span and no mirror or tap being used, it's interesting to find out who's yapping a lot. And these are going to be either broadcast, multicast, or flooded packets. So it's really important to understand. And you can see here's Mr. Roku spitting out IPv6 and IPv4 packets, 17% of all the traffic on the subnets from this guy. If I want to find out why, tune that down or choke him down or find out, is he even supposed to be on it, right? So on and so on and so on. So this is a very, very simple example of something you might want to do on any VLAN or any subnet. So there's a big difference between troubleshooting and doing some sort of application or VLAN discovery analysis, however you want to call it. Because when you troubleshoot, the concise goals are a little bit more tangible, right? The Server is slow, right? The router is slow. I'm dropping packets, those kinds of symptoms. Stay away from customer complaints that start with everything is slow. The app is slow. It is slow. Stay away from that because you can't measure that. You can't deliver on that. There is no real target or goal in that point. And that could be a moving target on a good day. So in this example, I just want to show you something. We've got a client here running an application. It's the accounting application, and he's talking to all these servers. Now, in some environments, you might argue, wait a minute, we've got more than one DNS server, we have load balancing, we have round robin, we have failover, we have, yeah. You can draw these out from an application level just to find out what's out there. You can go down to a layer 3 diagram if you'd like, or a layer 2 diagram, or a functional diagram. There's a dozen ways of drawing this out. The reason why we draw this out is two reasons. One, I want everybody sitting in the room, all the stakeholders, looking at the diagram to say, you're right, that's all the stuff that's involved. A lot of times you sit down with these people and they'll say, wait a minute, you're missing the authentication server. You're missing the tie-in to the cloud. You're missing that. And as you do that, a lot of other people like, what? We're still doing that? And so on and so on. So this is a great little, I'm going to say, jumping off point before you start capturing packets to make sure everybody's on the same page, including yourself. So what might you want to do with an application troubleshooting exercise? Well, who are the top talkers? What protocols are being used? I'm seeing a lot of IPv6 unintentionally being used on a network. So you might want to watch out for that. Dependency analysis, this is a whole other topic. And what it means is quite simple. For me, the application, to get to this web server, I need to depend on other services or servers to get that other piece to work. Good example, maybe you need LDAP, maybe you need DNS. And without those two components, you can't get to the web server or the SQL server. Now, it's not only an exercise of if this is down, it doesn't work. It's a better exercise of if something is going on with those devices or the path to those devices, then the whole application is going to seem slow, which is what most people complain about. Things going down are easy to fix. Things going slow are a lot more difficult to fix. So this is a good little example on how you start with an application troubleshooting exercise. I've been teaching people how to use Wireshark, and I've taught consultants how to consult for years. This is the biggest issue, right? I'm going to be generic right here. I'm going to include myself in this bucket. IT people are not very good documenters. We're too busy doing stuff. We don't have time to write stuff down. That's usually the argument I hear. In this example, I want to show you that just some very simple things will go a long way. Good example is within Wireshark, I can actually make a path and give a name to the files I want to save. In this case, I'm going to use a ring buffer. And it doesn't matter if you're going to do it every minute, every hour, how many files, none of that matters. The point is, this is going to be at the prefix of the file name. That's the important part. So as these files are being created, in this example, every minute, you'll see them pop up in the folder with that same naming convention. And this is incredibly important because you might have trace files for the SQL server, for the DNS server, for the web server, for the LDAP server. You want to keep those things fairly organized. And if you did save filtered packets, which I'm a big fan of, give it the same naming convention. Give the folders the same naming convention. Everything's going to be so obvious, nobody could possibly get this wrong if they want to review what you did a month from now, a year from now, 2 years from now, or you just want to compare apples and oranges in a few years. So this is a very, very simplistic view, but a good place to start. Stay organized. Get all your stuff organized. Now, with Wireshark or any other tool, if you decide to do this naming convention routine, I would strongly encourage you to test this out. So this is why it's only a minute. For the people wondering, why did I bother with a minute? Because I'm testing it. I want to make sure it goes to the correct folder. I want to make sure it has the correct naming convention I gave it. I want to see what's after the naming convention. So it's a good way to learn before you let this thing run for a day or 2 days or 3 days, and then find out you got to go back and rename everything manually. All right, the moment we've all been waiting for. We've got all that stuff out of the way, and now we're going to dive into some packets. Here's some tips, tricks, things you might want to do and look out for as you go through your packets. So let's do this one at a time. I'm going to get my little laser going here. There we are. So always start filtering at layer 2 to determine if IPv4 and IPv6 is being used and what that impact is. I cannot tell you how many applications I am actually working on, and they are using 6 and or 4, maybe a combination of both. And the client had no idea. Why? Because the client has all the stuff enabled, and so did the server, so on and so on and so on. It chose to do so. So you got to know what that means. Confirm that there's no ICMP errors. Like what? Not pings, like host unreachable, network unreachable. Here's a good one, that the destination is unreachable because fragmentation is required and the do not fragment bit is set. That's a very important one to know. If you rely on that, you should document it because things are just working because of it, and things might not work that well when it's gone or blocked, firewall, that sort of thing. Whenever you apply a display filter, review the endpoint and conversational reports in Wireshark. Now, if you didn't know this, in Wireshark, if you actually create a display filter and then you go to statistics and endpoints, for example, that chart, that table will be filtered. And there's a little checkbox where you can turn it off if you don't want to. It's a great way to find out what things look like with the filter and without the filter by just looking at one table. Get in the habit of documenting application dependencies. I just talked about that. I need to get to the web server. What servers, what services do I need to work for me so I can get to that web server? Like name resolution, right? Not only up, down, but slow. It's kind of good to know. If applications transfer a lot of data, make sure you're using the full-size packets. Now, I'll give you a quick example. If my TCP MSS is 1,460, and I find out in a trace that it's 1,380, that's not a big deal. That's not what I'm talking about. But if the trace showed me that my MSS was 256 or 512, and I'm doing these bulk transfers, or the application requires a lot of data to move, I'm going to want to find out why it's doing that, because I want to get back up to that 1460 or as close to it as possible. For applications that are more latent sensitive, look for packet loss. So the second example are latent sensitive applications. You want to make sure those packets come in order, and you want to make sure there isn't a lot of jitter. Use the delta time column, and this goes hand in hand with that last comment. So in Wireshark, if you turn that delta time on, and I've got lots of videos showing you how to do that, you can find out where that big delay is. That big delay points you towards that device, all right? And that's where you start moving your test points around so you can validate where that is. When using TCP, make sure you get the TCP three-way handshake and review the options. So here's an example of a three-way handshake, some of the stuff that you may want to pay attention to. Sometimes I take screenshots of this and I drop it on a PowerPoint or a Word document just so I can show people what I'm talking about, and it works great. Okay, what better way to try to explain this than to show you more examples? So here's an example of a receiving station complaining about a zero window. You can see the delta time shooting up to 5.5 seconds. Now, there's a few things to unpack from this screen. Number one, you have to have a good display filter. Now, you can either do it based on TCP port, you can do it based on just a conversational filter, a stream in Wireshark. There's many ways to get this to show you this type of format. But now you can start to prove the person sending the zero window is the one I want to concentrate on. Is it an application issue? Is it a hardware issue? It's just not keeping up. Who knows? But the goal here is to document what is happening, so when you make a change, you can verify that it's still happening or that you actually resolve the issue. So take screenshots, put them in PowerPoint, put them in Word, put them in an email, whatever it takes, and don't bore people with the details. Just do this. One screenshot, one circle, and say this is bad, so we don't want to see zero window. And that way other people can help you look for that. Why not? Let's look at another example. Here's a DNS example. We can see a DNS query going out, query, nothing, and then all of a sudden we see a response. So in this case, you want to find out what's going on. Don't concentrate on the typo. This is it's a misdirection thing I do in all my classes to see who falls for it. And people, oh, Gogole, that's the problem. Well, no, you might want to find out in your environment, what if the DNS name does not actually exist? That's another good test, right? In this case, believe it or not, it actually does go to Google. So in this case, we can look at transaction IDs. We can try to find out when things work, how long do they work, 45 milliseconds, and then all of a sudden it's 1 millisecond. Why is there a big discrepancy? Is the line congested? Is the DNS server being hammered? There's all sorts of things. But again, the goal here is document. So when you make a change, you can see if that pattern disappears. We also have over here that MSS I was talking about. There's 1460. We'll call that my maximum, for example. And the other end comes back at 512, which means the data is going to be flying across at 512 bytes instead of 1460, almost a third of the packet size. So that will impact your performance. Okay, let's wrap this up. And one of the best ways to wrap this up is with a display filter, believe it or not. I like kind of wrapping things up with that. Why? Because display filters help display obviously your packets, not to be too redundant with that comment, but there are different ways of displaying your packets or setting display filters. I would strongly encourage you, whatever protocol analyzer you're using, find out the various ways of filtering on your packets. Some of them will filter them based on IPs and MACs and TCP, UDP port numbers. Some of them you can do them based on application transaction IDs. With Wireshark, as long as I'm in the details screen, anything I right click on I can apply as a filter. If you're doing VoIP, you might want to find out if there's any VoIP specific filters that it will have for you. So get comfortable with the various ways that your favorite analyzer will filter your packets. You will find not all analyzers are created equally, and you will gravitate to a certain analyzer just based on its display filters and the ability to save those filters. You don't have to reinvent the wheel every time. So for example, Wireshark, you can type your display filter, you can create filters from the various statistics reports, you can right click on a flow, right, follow the stream, that kind of stuff. You've also got the option, as I said, to right click within the detail pane and create a filter from there. Now, the goal here is not to impress your friends and family at parties with all the various ways of creating a filter. It's to find out which tool does it best for you for that scenario. And again, I really hope you do this because you will find certain analyzers will actually help you troubleshoot certain protocols a lot better than others. So I hope you enjoyed that. Have a good day. Bye for now.